Hey everybody, quick video on how to graph reciprocal trig functions. Should be awesome. It's time for math with Mr. Troy. Alright, say you want to graph a reciprocal trig function like this one. You're going to start by graphing its reciprocal. So for example, for this one, you'd want to graph y equals -2 times the cosine of 2 theta minus pi minus 1. Eventually you get to a place where you're good enough at this that you don't need to do that, but it's a really good thing for you to do for now. All right, some of the things that you always want to do, you always want to factor away the theta, or the 2 from the theta. So we know that instead of starting this function at the origin, we're going to start at pi over 2 to the right. Okay. Now, we can see that our midline is shifted down to -1. So I'm going to put that on here. Oh, gravy. Having trouble. Here we go. So we put our midline on there. Now, the cosine would normally be high, middle, low, middle, high. Okay. Remembering that we're going all the way down to here because we have an amplitude of 2, and all the way up to here. So normally the cosine goes high, middle, low, middle, high. But because we're multiplying by -1, we're going to go low, middle, high, middle. Oh. See, this is where it gets complicated because there's a lot of stuff going on. The period is compressed. It's 2 pi over 2. So the period is pi, which means that these points are less spaced out, right? So instead of going over a period of 2 pi, my period is going to be pi. So the entire curve is going to be fitting in between pi over 2 and 3 pi over 2. So it's going to go low, middle, high, middle, low. And you know what comes next. I pause the video and I draw that curve in. Okay, so that is just how you graph kind of the ghost graph or the guide graph for the secant. You graph its reciprocal, the cosine. Now, I want you to stop and I want you to pause and I want you to pick any one of those x values on the midline and plug it in and see what you get. You should get that it's undefined. Now, that midline kind of acts as the 0 because we're moving our function down 1. Sorry, this function down 1. So it kind of acts as our 0. If we take the reciprocal, we're dividing by 0. So that's going to give us a vertical asymptote at all of these places. Whole bunch of vertical asymptotes. So anywhere that graph hits the midline, we have a vertical asymptote from the graph we're actually trying to graph. Now, if you plug in any of these points, you're going to get the same value. So each of these points are going to have the same value. This is why I was referring to this as like a ghost graph or a guide graph, because they end up having the same value. And then the way that the graph works is that as these values get very close to the midline, the reciprocal of that distance from the midline gets really, really small. The reciprocal of that would be very, very large. So it takes this nice curved shape hitting that point we already graphed and approaching the asymptote going towards infinity. Now the same thing happens underneath. So the graph would look like this. And I had to extend my graph, but that asymptote still is there, of course. So we end up getting a graph that looks like this. Now, one thing that I think that's important to remember is that it takes one top half and one bottom half to make a period of this graph. Some people will mistakenly assume that just this top curve is one period, and it's actually that entire distance is the period, and that's what it takes to make one cycle of the graph. All right, hope that was helpful.